Hello. Today we're going to keep going with solving our trig functions, and we're going to solve trig identities. Yesterday we worked with linear and angular speed, which is trig functions. Today we're going back to the sine, cosine, tangent, and we're going to simplify some trig identities. One of the things that we want to look at here, and I'm not sure that this is going to show up, but identity is a mathematical statement that is always true. Okay, that's an identity, and it's not showing up, so I'm not going to do that anymore. Okay, an identity is a mathematical statement that is always true. Some of the trig identities that we have is the cosine. The cosine of an angle is x. The sine of an angle is y. And the tangent of an angle is sine over cosine, or y over x. We have the secant. The secant of an angle is 1 over the cosine of the angle, or 1 over x. The cosecant of an angle is 1 over the sine of the angle, or 1 over y. And then the cotangent, which is the cosine of the angle over the sine of the angle, or x over y. We can use basic identities of trig functions to verify other identities. To verify an identity, you can use the previously known identity and simplify one side of the equation. Okay, so it's going to look like the other. But to begin with, let's just try simplifying. Let's simplify. And if I could give you a hint, take everything back to begin with to sine and cosine. If we take everything back to sine and cosine, then it could be easier to simplify. So let's look. The secant. If I look up here, secant is 1 over cosine. So I can put 1 over the cosine of the angle. Always add your angle down there, please. Okay? And I'm multiplying that by cotangent. The cotangent is cosine of the angle over sine of the angle. So I have cosine of the angle over sine of the angle. Now, if I'm looking, and remember back to simplifying even rational expressions, the cosines will cancel. I am left with 1 over the sine of the angle. And 1 over sine of the angle is cosecant of the angle. That is how we simplify. So when I simplified secant of the angle, cotangent of the angle, I now have cosecant of the angle. So this is just like algebra with words in simplifying. Let's try the second one. Here's another example. Remember, I am taking everything back to cosine and sine. So cosecant of the angle is 1 over sine of the angle. Cotangent of the angle is cosine of the angle over sine of the angle. And then cosine of the angle is cosine of the angle over 1. Right? And that is over cotangent squared of the angle. Cotangent squared is cosine squared of the angle over sine squared of the angle. Cotangent of the angle is just cosine over sine. So cotangent squared of the angle is going to be the cosine squared of the angle over the sine squared of the angle. Now, we're going to remember, if we divide, okay, we have a fraction and we're dividing by another fraction, we multiply by the reciprocal. So I'm going to simplify the numerator. This is going to be cosine squared of the angle over sine squared of the angle. I do that because I have 1 times cosine, cosine squared, and that's all divided by sine times 1, sine squared. Now, when I multiply this by the reciprocal, I have sine squared theta over cosine squared theta. And if you look, everything cancels. I simplified this to 1. Ooh, I love that stuff. Okay, you have 3 to do here, and then verifying. I am not going to do your verifying because we're going to move on, but verifying is very easy. I like it better than simplifying because to verify the identity, I take the hardest side, okay, and I do the same thing with simplifying, but I know what I'm supposed to get. So I'm going to take this side right here, cosecant of theta over secant of theta, okay? And I'm just going to work with that one side, but I know that what I'm supposed to get is going to be cotangent of theta. It's fun. Those are fun. All right. So that is simplifying and verifying. And now I want to go over here to the Pythagorean identities. And we know the Pythagorean theorem is a squared plus b squared is equal to c squared. And c squared is their hypotenuse. Well, what we've been looking at on a unit circle is the sine of an angle, the cosine of an angle, and then we know that it's a unit circle. So the hypotenuse, the radius, has always been 1. So that's where this comes from. The sine squared of the angle, okay, plus the cosine squared of the angle is equal to that hypotenuse squared, which is 1 squared, or 1. That's how we can come up with this Pythagorean identity. So this is something that we will use quite a bit. Sine squared plus cosine squared is equal to 1. Right here, this is what we can use if we have divide the whole thing by sine squared. Okay, if I divide it, I have the sine squared divided by sine squared of theta. Sine squared over sine squared is going to be 1. Cosine squared over sine squared is cotangent squared of theta. And then 1 over sine squared is cosecant squared of theta. So this is one that we are going to use, okay? So we can rewrite this equation down here. We can also rewrite it as in the cotangent squared of theta. If I subtract 1 from both sides, is the cosecant squared of theta minus 1. So now I have sine squared plus cosine squared is 1. 1 plus cotangent squared of theta is cosecant squared of theta. Cotangent squared is equal to cosecant squared of theta minus 1. I sound like I'm teaching a new language, but the same principle goes here. If I divide everything by cosine squared, sine squared of theta plus cosine squared of theta is 1. Divide everything by cosine squared of theta, and then simplify it. Sine squared of theta divided by cosine squared of theta is tangent squared theta plus 1 is equal to 1 over cosine squared of theta is secant squared theta. So if I rewrite it, isolating the tangent, tangent squared of theta is equal to secant squared of theta minus 1. And now these right here are, let's try another color. These right here are the Pythagorean identities, and you're going to be able to use those to solve and simplify identities also. Remember, I am here to help you between 10 and 11 and 1 and 2. Have a great day. Bye.